welcome to my workshop. Today's video is brought to you by Thunder Laser. Now in today's video we're going to do some 3D experimentation on some very special material, and that is cast acrylic. So I have a grayscale test CAD already set up in Lightburn, and I'll take you over to the screen now and we will set that up for a test burn. So with a 3D picture and a laser, you are dealing with a grayscale picture, or sometimes called a height map. So I'm going to set this up. So we're going to open this up and we are going to alter some of these feeds and speeds. Now for acrylic I'm going to bring this down to 300 millimeters, which is roughly about a foot. Maximum input. Now this is set up from a 3D engraving that I did actually with the Mona Lisa, but this is set up for wood. Now acrylic will actually evaporate to a gas, and it does it at a lower power output than what this is set at. So I am going to take this all the way down to 50%. There we go, that's 50%. And I know my laser will drop out at 2%. In other words, it won't fire under 2%. Now bearing in mind that this is a 100 watt CO2 laser, so if I'd have left it at 95 or 99% output, it would make a mess of the acrylic. In fact, that might even be a little bit too high as well. I'll leave it at 50 for now and run the test, and we will be able to determine whether it's too high or too low. But I think, to be quite honest, I've never engraved acrylic plastic on the Thunder Laser before, and I do know that the Thunder Laser, compared to my other 100 watt laser, well, it's much more efficient, and well, not only efficient, but it seems a lot more powerful than what my other laser was. So I'm going to leave it at 50 and we'll go with that. 0.1, yeah, I'm going to stay with that. So in other words, that's 10 passes for every millimeter, which is about the size of the dot of the laser running at this speed. 254 dots per inch, that's okay as well. Grayscale. And you really don't have to do anything other than ensure that your air blowing is turned off, because you do require some air blowing, but not a lot, and especially with acrylic plastic, because you will end up having a build-up on the end of your nozzle and making a bit of a mess of it if you blow too hard. So that's about it. Don't have to alter anything else at all. Don't have to modify the colors or anything like that. And we're going to say that's okay. Oop. And now I'll transfer that to the Thunder Laser. So before you start any sort of procedure. This should be a daily check really, and that is you need a good clean sort of cloth. So what I'm going to do is I'm going to check the lens here. So you just press down on this, pull that out, undo that milled wheel, slide this out, and you can see the camera's picking that up. See all the way down in there? Not a speck of dust. Okay, so that's how it should be. You should check your lenses daily. Well, and your mirrors for that matter too. I've already looked at my mirrors and they're all okay. So, having checked that, you know there's not going to be any problem at all, or if you do have any sort of problem, well, you've already looked at those. And you just push that back in there and it's done. Now, acrylic is can be funny stuff to actually work with. It's actually very good for a laser to work with because it evaporates away to a gas. Now, remember what I said there, it evaporates to a gas. But that gas is still poisonous. So you need to evacuate that gas, the resulting gas, out of the machine. Okay? And you do need to put it through, and I'll just turn the camera round a little bit. This system here is a pure air system. That big box there. Now that's got the extractor fan inside it, a good strong one, and that puts the air through a series of cartridge filters, and the resulting air that comes out of the exhaust is 99% pure, and the resulting air that comes out is just air. So you can vent it back into your workshop. Now I see a lot of people just venting it outside. Just consider your kids or your neighbour's kids playing outside, breathing that in. It's carcinogenic. Anything that you put in a laser turns to a gas or smoke. Particularly wood, man-made wood like ply. That's all put together with man-made glues, and you're turning them into a gas. So just be mindful of that. Okay, acrylic. Now, the Thunder Laser has an IR system for focusing the lens, the end of the nozzle here. Okay? Now, glass and acrylic, it is possible that the IR system won't pick it up. Alright? And if you try to focus and it doesn't pick it up, you're may do some damage with your nozzle. It'll drive it into the material. Okay? So what you need to do is a very simple thing, is just where you're going to put this, align this in with the IR sensors, which are just at the back there. You put a strip of just ordinary masking tape either side, like that, and the IR will pick it up just fine. And if you put glass in here, you need to do the same with glass as well. okay, because the IR is possible to pass all the way through it and not see it. Okay, so that's the quick remedy that I always use for acrylics and glass. So now we will set the focus on it. Okay, so I'm just going to drive the table down and take the head back. Okay, so the IR sensor is here and opposing it over the other side there, so this is in between. So now I'm just going to press menu, and the first window that's highlighted that comes up is autofocus, so I press enter, and that now is perfect. So now I'm going to bring the material right forward here, because I've taken this panel out and I normally video through that so you can see what's going on. So when you're dealing with acrylic, and especially when you're doing an etching, engraving or 3D carving, whatever you're doing, apart from cutting, you need to have low blow and just a small amount of air through. I'll just show you. I'll just put on the high blow. That's really going through there. This is low blow. So you notice the difference there, but that's still too much. Now, you sort of got to judge it yourself. So you can just feel it coming through there. All you're doing, all you want to do is have enough air coming in here to cool the lens and blow any material out. You know, not letting it go up through to the lens, and just evacuating it from the surface. That's all you want to do. And don't forget, it's a gas. And you don't want it to accumulate on the lens at all. So you only want a very small amount of air going through. Alright, so we will set up our datum point and we will see what happens. Okay, so all the time I have sort of been setting this up, I have not actually had the laser tube switched on. And that's probably a good practice to incorporate into the way you work. So I'm just going to turn the laser on now. So it's just the pump is just purging the laser, and it will just run as in the aircon unit will come on and switch off. Okay, it's just cut out. I'm going to put my pure air system on. Okay, so that's running, and let's press start. Well, that came out pretty sharp actually. I'll just take a look, see how deep we went, and it's at 100%. Okay, so we're reading pretty well, reading 0 there. I know this is 100%. 0.7 of a millimeter. In inches that is, oh, change to inches, there we go. So 28 thou, which is at 50%, that's not bad. That's pretty good actually. So, I think you can see by that test CAD that if I'd have run it at 100% or 99% power output and down to 2, like I would do for a hardwood or something like that, it would have made a mess of that. It would have been too powerful and it would have melted, you know, sort of, you wouldn't have nice crisp letters or anything like that. It'd just be a blob mess. So I would say that 50%, maybe 55% maximum power, but I would tend to leave it at 50%. That's 50% maximum power and 2% minimum power, because I know my particular tube drops out at 2%. Okay, so let's now do a 3D engraving into acrylic. Now this is going to take approximately, as we know, it goes down 0.7 of a millimeter, 28th out. We're going to want to go down about 5 millimeters, so that's 6 passes. We'll see as we go. Now with acrylic, I don't think it's going to be necessary to actually refocus further down, because what we want to happen is on the very last pass is to be slightly out of focus, and in that way it will give a bit of a polish cut, and it hopefully will get rid of all of the white powderiness that you're left with. Okay, that's the only way I know of getting rid of it on acrylic. Okay, so I've got a little test CAD 3D engraving in grayscale. Okay, so let's prepare this 3D engraving. Okay, so let's start a new job. No, we don't want to save that. And we're going to import, let's zoom back out. Import. Okay. How big is this? I'm going to make this a little larger. I'm going to make this, let me see, 87. Oh, it's not bad. You know, I'll leave it as it is. And it's nearly 90 mil, nearly like 3.5 inches or so, 3 3/4 inches high. So I'm going to leave it at that. So, image. It's a grayscale. I'm going to leave it at that. I'm going to leave these settings as they are, and let me see, 0.1. Yeah, I'll leave it at that. I think 0.1 is fairly fair. I think maybe the last pass I might knock this down a little bit and make it 0.8 or 0.7, because we want to sort of flame cut it, flame polish it rather. That resolution is fairly, that's okay. Alright, so we'll okay that, and we'll send it to our laser. you will notice that I have changed the model or the graphic that I was cutting, because what I found out was after a few passes it was making an absolute mess of it, and I went back in and looked at the source material, and to my surprise it was very low resolution. So I know this particular one that I'm doing now is a very high resolution, so that matters, especially when you're doing a 3D engraving. So this is much better. Okay, so as you can see, very little debris on it, and it is a very, very good 3D engraving into acrylic plastic. But I've used a couple of tricks here. First of all, I have raised the focus 3 millimeters over and above what it should be. So instead of 6 millimeter, I had this at 9 millimeter above the material, and also as you take each cut, that figure increases. So down into the bottom of the 3D relief to the underside of the nozzle is approximately 13 millimeters or half an inch, which is slightly out of focus. So what I'm going to do now, I am going to give this a laser flame polish. Now to do that, I am going to drive this table down at an additional 3 millimeters. So it is out of focus, only very slightly, but it is out of focus, and I'm just using the laser to, should we say, get rid of any laser marks that may be in this material. It's actually very smooth, and let's give that a go, and I think it'll be perfect. So I've got some gauge material here. Let me zoom you out a little. And you also need the air blow system turned right back. Only just crack it open so the air is just coming through and cooling the lens, and only just moving the slightest amount of debris out of the cut. So I'm going to have to get down on my hands and knees for this. Oh, here we go. Because I want to see what's going on here. This is 2 6 millimeter pieces of aluminium actually. I'm going to use as gauge blocks. Okay, that's it. Okay, so here we are for a polishing cut. Okay, so I'm going to cut this out now to finish it off. Let's just run a frame. I think that'll be fine. So all I've got here is a wet wipe. I mean, you could just put this under the tap. Pretty clean cut through, no problem at all. Look at that. I don't know whether... Let me get a black piece of CAD and put behind this, you can see it better then. Okay, so I can get the light right. Really deep 3D. I don't know whether it's... Yeah, you can see it better with a CAD. Okay. So you can get a perfect result. I mean, you know, this is just a little test piece of a 3D dragon. He's I think you can see that. He's about 5mm deep, or they're about 4.5mm deep. But there are some secrets into getting a perfect, near perfect result. I probably could have got even a better result if I'd done another cut and possibly another 3mm out of focus. So there is some of the secrets of getting a perfect, near perfect 3D design into cast acrylic. Without gumming your nozzle up and you know, and making a mess. As you can see, these first 3D cuts were horrible, and I had to run this one a couple of times and have a look at it to see what was going on. And I could see then that, oh, I think I better check what resolution this picture originally was. But it was low resolution, and that is the difference. This is a very high resolution, and it has to be high resolution. You know, for a laser as well. You know, you can get away with it with a CNC router, but you can't with a laser. So I don't know whether it's particular to a Thunder Laser, but I got the best results. I ended up being, when I initially started with these, I was in focus, and I could see that it was not that it was too harsh or anything like that, but that there's a balance between the amount of evacuation air that you have coming out and the speed of travel and the power output. And I have found and proven the best results in acrylic for a 100-watt Thunder Laser machine is 55 maximum 8% output and 2% minimum. 300 millimeters per second and a step over of 0.1 of a millimeter. Now this is a 2.5-inch lens. I've actually not tried it with the high definition lens. I may give that a go in a few weeks to see how it performs, but in my mind the way I think is that the high definition lens from Thunder Laser is for transferring a photograph onto wood or plastic or glass. Now that's what I would use it for, but it may be okay for 3D engraving onto acrylic plastic. Don't know. I'll have to give it a try. So yes, so you know, you've got to balance the output, the speed, and the amount of air blowing. Very small amount. All you're really after is stopping any build-up on the end of the nozzle and to keep the lens cool. That's all you're after with it. Don't totally turn it off because you'll end up cracking a lens. Or you could end up cracking a lens. And what then turned out to be most important, and that is particular to my Thunder Laser, I would say it would be the best results for all of them. And that is when you initially start off, you want to be 3mm out of focus. In other words, I think if you focused it with the automatic setup, that takes you, I think, 6mm off the material. Well, you want to be 9mm off the material, and do your cuts with that. Now I did, let me see, 1, 2, 3, 4. I did 4 cuts on this, okay, and it got it down to 4.5mm thereabouts. For the size, for the overall size of the 3D relief, you really don't want to go any deeper than that, because then it sort of goes distorted, I think. So, but at the moment, that is absolutely perfect. Every little detail, every detail. Little flowers here, and even the little ribs on the you know, on his back, scales rather, not rib scales. They're there. And not forgetting, of course, your very, very last cut, I put it an additional 3mm out of focus, purposely to polish it. Okay, so you're not really cutting very much. You might be taking off a couple of thou, but what you're after is to polish it. Okay, there will always be, you see in the background on the sort of back wall, then there will always be slight marks there. Maybe if I'd have run the polishing cut again, maybe I could have reduced those. Don't know. We will do some further tests with the Thunder Laser 3D carving into acrylic, but very, very pleased with the outcome of this. My other 100-watt laser wouldn't have come anywhere near this. This video came about through one of the Thunder Laser customers having a little bit of a problem doing this type of work into acrylic. So this is how you do it. And I think there was another question as well about, okay, I've got a 100-watt machine, of which this is. This is the NOVA 3500 watt. And I think the customer had an 80 watt, and he was asking about the settings. Well, the speeds and the feeds and the focus and the air would be identical. The only thing that you would alter is the maximum power. Now, you're going to have to do a few test cuts with it, and I would suggest that it would possibly have to go to somewhere between 60 and 65 maximum output. But you would also need to find out at what percentage your laser tube actually drops out. In other words, doesn't fire. The minimum that it will fire. In my case, it's 2%. Your laser might be 3, 4, 5, 6%. Okay, so you're going to have to work out what that is. Do a couple of tests. So a few minutes ago I mentioned high definition lens, Thunder Laser's high definition lens, which I have, for photographs onto all sorts of different materials, wood, acrylic, glass. I think in the very near future we'll give that a go, and probably we'll start off on CAD or paper, and we'll do some high resolution photographs. And of course you don't need to have any other program than Lightburn to actually process the photographs, so you can do it all in Lightburn. So we'll be diving into the Lightburn a little bit, and I'll show you how to, or the settings that I use, or how I sort of manipulate a photograph to be able to, for the laser to do its best with it. Okay, so if you like the video today, and if you've got this far, you probably do, like and subscribe. If you don't like what I'm doing, I probably should say this at the beginning, tell everybody. If you really like what I'm doing, you could consider becoming a patron to the channel, because there's just, there's no revenue on YouTube these days. It's the patrons behind the channel that allow me to, or assist me to, make high-tech videos for you all to watch. So until the next video, and I hope I see you again, it's bye for now.